I'm Diksha Gupta of grade 8, a student at Sushrughya School. And today I'm going to be showing you my findings of something called a density calculator of an object without knowing its mass and volume. So, the uniqueness of my project is that, like its title, it calculates the density of an object without knowing its mass and volume, but calculates it using the density of three different liquids. According to my knowledge, this project has not been conducted by anybody else. So, the materials required for this experiment are two unknown objects, from which we will find one of its density and the other one is for reference and to help balancing. Then, for my three different liquids I used water, groundnut oil and mustard oil. Additionally, I used a ruler, a beaker to pour the liquids in, thread and a scooby wire. So what I did is I took my two unknown objects and tied a thread around them. Then I tied a scooby wire around the center of the scale tightly. So the distance from the center of the scale to my first object will be x1, and the distance from the center of the scale to the second object will be x2. I determined the values x1 and x2 through balancing the objects. The value of x1 is going to change when we calculate the values using the different liquids, but x2 always remains constant. As you can see here, the first object is heavier than the second object. So we are going to balance it by moving the first object closer towards the center of the scale. If an object is lighter, it can be moved outwards with respect to the center of the scale. At last, I received a balance, with my x1 measuring 9.5 centimeters and x2 measuring 14 centimeters. Now, I'm going to find my x1 using water, and x2 is going to remain the same. As you can see, I dipped my first object into water, and then the balance attained was lost, and it became unbalanced. This is because of something called the buoyant force. The force comes from the pressure exerted on a liquid, and in this case, the pressure is my first object. Now, because the pressure increases as the depth increases, the pressure on the bottom is greater than that of the top. Hence, the upward thrust, resulting in an increase of the weight of the first object, imbalancing the scale. Finally, my value of x1 for water was 11.3 centimeters. Also, the density of water is 0.997 grams per centimeter cube. Moving on to balancing with groundnut oil. As you can see, here I have my objects and a container with groundnut oil. The density of groundnut oil is 0.93 grams centimeters per cube. So, my final reading of x1 with groundnut oil was 11.1 centimeter. My last liquid is mustard oil. My value of x1 with mustard oil was 11.2 centimeters. Also, the density of mustard oil is 0.96 grams per centimeter cube. So, this is the equation I used for calculation of the density. Here, rho 3 is the density of the given liquid. That can be water, groundnut oil, or mustard oil. These are the substituted values and my answers. For water, groundnut oil, and mustard oil. This is a table of my observations. My inference for this experiment is that the density for the object using the different liquids are approximately the same. Also, I verified my calculated density through the actual mass and volume of this object, and it matched with my calculated density. My inference proves my hypothesis correct. Thank you for watching this. I hope you've had a good learning experience from this experiment. Have a great day.